Hello everybody and welcome back. Today we will talk about the interference of sound waves. What's meant by the interference of sound waves? This expression means what happens when two waves of sound meet together. So, for example, if we have a source and another source, each of them produce sound waves. So, what happens when these waves meet together at certain points? This can be observed when two speakers work together side by side. Each of them produces sound waves so that the waves can interfere at some points. So, as we can see here, we have source number 1 and it produces sound waves so that we have the first wave here, the second, the third, and the fourth wave. And we have source number 2, same thing, we have 1, 2, 3, and 4. So the lines in red express the rarefactions, the lines in blue express the compressions. So we can notice that the lines meet at these points. So, first we will talk about the points where the red lines meet, so that the rarefactions of the first wave meets with the rarefactions of the second waves, and the compressions of the first wave meet the compressions of the second wave. So the points where the rarefactions of both waves or the compressions of both waves meet are called the antinodes. They are called the antinodes. While the points where the compressions of one wave meet the rarefactions of another wave, or vice versa, the points where the rarefactions of a wave meets the compressions of another waves, these ones are called nodes. So, the points on the green light here, we can notice that rarefactions meet together, compressions, then rarefactions, then compressions. So these points are called antinodes, and the green line is called the antinode line. Also, here, this line is an antinode line. Also this one. While this line here, that one is a node line. This is a node line because here the rarefaction from source 2 meets a compression of a source 1, as we can see here. Also this one is a node line. These are the sources of the sound waves. So, what happens at the antinodes and what happens at the nodes? We said that we are talking about sound waves interference. So, at antinodes, there's something called a constructive interference. so that the interference between the rarefactions of both waves or the compressions of both waves strengthen the sound waves and makes it more stronger. So it works as a constructive tool. That's why it's called a constructive interference. While what happens at the nodes is called a destructive interference, because when the compressions of a wave meets the rarefactions of another wave, this makes the sound waves weaker, and this causes some kind of destruction to the sound wave, and that's why it's called destructive interference. Finally, there is something that we refer to as PD, and it's called the Path Deferens. So what's the path deference in the interference of sound waves? The path deference is the distance of the path of a certain point, let's say this point, from both sources of the sound emission or the sound production. So, if this point lies on the node line, the placement of the point equals half plus m multiplied by the wavelength. What does this mean? Let's talk about the distance of this point from the source number 1. Here we have first 1, 2, then 3. So we have 3 wave lengths. Okay, we have 3 wave lengths. So the placement of this point will be half plus 3 multiplied by the wavelength. And if the point lies on the antinode line, its placement will be m multiplied by the wavelength. So, if we deal with this point here, we will have 1, 2, and 3. So we get directly 3 wavelength. We add the half here because there's kind of deviation from the anti-node line, the main line here. So we add the half. So this is the path difference. In order to get the path difference, we get the placement of the point in the anti-node line from the first source, the second source, we subtract them from each other, and we get the path difference. So for example, the path difference of this point, it will be here 3.5 from source 1. And here we have 1, 2, 3, and 4. So we get 4 because it lies at a distance of 4 waves from the source. So we have here 4.5 and here 3.5. 4.5 minus 3.5 gives a 1. So the path difference of this point is 1. So this is it for today, and the next time we will talk about the sound diffraction, and till then I thank you for watching and see you.